what we wanted to do was really, here in the second of the four-part series, go through our remote diagnostic and some of the capabilities that we're headed to in 2020 and some things that we're doing in 2021. So today we're going to dig a little more into the details, whereas last week we stayed very high level. We went through empowered, what it means to our customers, and then kind of set it up for this week and the following 2 weeks after this to really dive into the details about real world examples and how we help customers. So today, again, we'll cover the remote diagnostics section. I think we've created a link so that you can go back, make sure if you missed anything, you can rewatch it, just to kind of go through and connect the dots, or if you missed it altogether, go back and experience it for the first time. Last week when we started, we wanted to really provide our audience with a relational topic, so we tried to talk about and relate this back to the user experience today of driving a vehicle. So there are a lot of things that we've put into technology today that make the driving experience much better, in a lot of forms and a lot of capacities. So a lot of tools and technology as far as GPSs and their innovation, different things that help you understand the car, different features like OnStar that help connect you to people when there's emergencies, or send you alerts and warnings for maintenance items that are due, or things that your car you might not be able to put on a dashboard, but that you can put in a nice format. There's just a lot of things that have been put into this experience to make it better for the user, better for the driver, and much safer for everybody on the road, and easier to operate. So, again, with that concept today, we wanted to jump into a specific piece about the technical support and what we're doing. So again, our relational concept this week, we're going to focus on a certain portion of the vehicle and a certain portion that has made it easier to own a car, and better all around for the user and the experience. So that piece today is going to focus on the maintenance dashboard, the things that come up to you, check engine light, your tire deflation light, all these things that say, yeah, there's something probably going on with the car. Car providers, automotive manufacturers have built into this today to send you automated emails, connect you directly with somebody, plug in a computer, and tell you exactly what needs to happen on that car. They give you the ability to do that, or there's a lot of automotive people out there today that want to come in and help you close those gaps. So really, when we go through this today, that's what we're trying to relate back to. We're trying to make this experience as easy as possible for our customers, provide the most meaningful knowledge, to either turn those lights off or help you before those lights come on altogether. So last week you saw this high level slide, detailing one of the applications in our suite that we call technical support. This is our ability to remotely connect to the equipment and help with diagnostics. So we mentioned some of the things at a very high level last week as far as issues that we've solved, and we're going to spend quite a bit of time today actually going through real world scenarios of things we did solve. We're going to set the stage and kind of talk through those and show you what customers have experienced. Again, some of these are things that we've solved completely. Other things that we'll talk about as we're going through these examples, we're able to help customers reduce downtimes, even if we can't eliminate them altogether. Where 1 in 5 was the latest metric, or the first metric we pulled. This is actually getting closer to 2 in 5 issues, and we actually expect that to keep growing as we experience more, and as we learn more with our customers about how we can leverage these remote connections to provide detailed and high levels of service. I'm going to go ahead and jump into our case studies today. We've got 4 for you. So the first case study, a customer had called us with an alarm that is accumulator charge pressure not made. So we frequently use accumulators to perform certain functions of the machine that might not have enough horsepower from just a general pump stack or pump setup. These often perform many functions, but again, when you see alarms like this, it can be somewhat difficult if you're not familiar with the accumulators, you're not familiar with how they enter or how they operate with the accumulator or the hydraulic package, I'm sorry, of the machine, to really understand and start to troubleshoot these features. So here, what you see is an example of some of the things that our technicians have actually done using this system to try to help our customers. So with this, they were able to look at four specific issues or four specific things that really helped us narrow down and get a handle on what this issue was. We were able to look at the actual feedback from the accumulator itself, a transducer that's in the system, or the drive feedback of what we're asking the accumulators to do. We're able to look at the pump that charges the accumulators and make sure that it's getting the proper command and the proper output. And we're also able to say, okay, let's relate this all back to what it's being asked to do and see if it can meet those needs or meet those requirements. Utilizing this data, we were actually able to eliminate quite a few things. We're able to eliminate the software side of things. We're able to eliminate certain changes that users, technicians, or any kind of operator could have made. And we were able to quickly see that, yes, when we got this error, we can actually trace and see that the accumulator was not quite reaching the set point that we were asking for. So you can see here on the graph, it might be a little grainy here, but it basically says, long story short, that we hit 167 out of the 190 bar pressure that we were asking that system to reach. With our technicians' knowledge and being able to combine not only themselves on the phone, but our experience in the shop and some of the experience around them, we were able to look through the hydraulic circuit and kind of identify some potential areas, work with the customer to eliminate a few things, eliminate bad accumulator bottles or bags in those bottles. And we were actually able to very quickly get that down to a likely transducer issue with the system and with the setup. So with this particular solution, luckily the customer had a machine that they were swapping a mold on that they didn't need for a couple days. So they were actually able to take what was a similar transducer part number off of that machine, put it onto this machine, and get the machine back up and running very quickly. So with this, you'll see a common theme as we go through these four of how many hours that we estimated that we've saved to the customer in downtime, just to put this back to a relational number for our viewers here on the conference. But with this, we estimate we weren't able to get a technician in that day. It probably would have been a day or sometime that next day that we were able to get someone on site. But we were able to eliminate all of that time spent waiting for the technician by connecting to the machine and being able to look at these things real time and provide real life recommendations. So in our second case study, a customer very similar had called us with an over tonnage alarm on clamp retract. So as most of you know, if you're familiar with an injection molding machine, so this is these case studies we have on here. I'll talk about some of the extrusion side and some of the things that we've done here, but we chose to focus on these because they were relevant. They were here, and we had some good data behind them to show. So if you get the feeling that we're only focusing on the injection side, I apologize, and I'll try to talk a little bit about the extrusion side as well. But with this particular issue here, if you're familiar with the injection machines, as I stated, as that clamp starts to travel backwards, it's very difficult to have an alarm that says you're getting over tonnage. So over tonnage, you would typically think, okay, the mold touches, it's building pressure, and eventually I got over my pressure set point, and there's an issue. But in fact, on this one, the customer called us and stated, yes, it's actually getting an over tonnage alarm, but it's when the clamp is moving backwards. So that immediately throws flags, right? As to we have to confirm that this is an actual issue and it's occurring when the customer says it's occurring. Sometimes things can get lost in translation, and we want to verify. So we were very quickly able to connect to the control, see that this issue was actually occurring, and then from there we dug down and started plotting and looking at what is the clamp doing, where is it while it's operating, what is the transducer output saying, and how is our drive and how is our system calculating what that actual tonnage is, so that we can try to eliminate any other occurrences outside of the issue actually happening. With this setup, we're zooming in here on a particular piece of that graph from the previous page. You can actually see while the clamp is retracting, a spike in the tonnage readout for this particular machine. So we were able to verify, yes, this issue is actually occurring. It's something that the transducer is actually seeing. It's likely that the transducer is good. It's likely that the software is good, but we're still getting a very, very strange issue at a point where you shouldn't be able to have this type of problem. So with this understanding, and again with this knowledge, our techs were able to work with the customer, eliminate a few potential items, and get down very quickly to a connector or cable issue. After working with them and kind of tracing through where that line wiring goes back through the clamp back up to this particular item, this transducer, we were able to locate with the customer a broken pin actually in the circuit. So something as simple as movement had caused a pin to come loose out of a connector, and fractured the pin. So every time it would get to a certain position, it was causing that pin to hit a certain way, and causing the signal to increase and make it look like there was an actual issue. The customer was able to quickly get this out, repair it, and they were back up and running relatively quickly. But again, this is another issue where we couldn't necessarily have a person on site instantly when it happened, and it would have likely had to have been the next day before our tech was in. But utilizing the system and utilizing the data behind it, we were very quickly able to provide accurate recommendations to repair this item and get the customer back up and running. With that, I'm going to jump into a couple additional case studies. With these, we're not going to go into as much detail. I think you guys get the picture with the first two and some of the reports and some of the things that we're showing that we can do. But we also wanted to hit on these because they show a couple additional sides and things that are pretty special to the technical support aspect and being able to touch and see these things remotely. So the first one here happened to be a pump one priming issue. So pump one priming alarm, meaning that when our machine is trying to check the state of the pumps and the health of the pumps, we do this at startup and we ask it to reach a certain pressure. If it does not reach a certain pressure within a certain time, our machine gives an alarm and says that there's likely an issue with this pump and we need to check it. Now, with us having linked pumps and other things going on in the system, sometimes you can have certain items that necessarily aren't reflective, or certain alarms that aren't reflective of the actual issue. And this is one that we're trying to use this data to get better on. And I'll talk a little bit about that once I get through the issue here. But um, this one in particular, the pump, we were actually able to connect and see that it was not reaching the minimum pressure to pass the sequence. So there is in fact an issue. But what our tech also noticed is that the extruder motor was turning while this pump was trying to build pressure. Well, what the pump should be doing is dumping back to tank. And with that, there shouldn't be any other oil flowing through the circuit. So our tech was very quickly able to trace through the circuit and find potential issues. And we pointed the customer to a directional valve, and they actually were able to take it off, and it was stuck in a run position. So we were actually able to guide them to that. They were able to clean out the valve in the port, reattach it to the machine, and get back up and running again very quickly. The thing that we want to point out with this particular case study is some of the complications that come along with these issues. So, where pump one priming alarm may come in, and some of our diagnostics on past machines, they might not point you directly to the issue, but these are ways that Milacron is starting to take this data, categorize it, and in a few slides, we're going to talk about how we're proactively saying, did this point the customer to the problem? If not, how can we send things proactively to our customers that are potential causes or potential solutions to fix this issue? And how can we build new things and new technologies into new controls that may help us alleviate these things altogether and improve the quality of our machines and the data that we deliver to our customers? In our fourth and final case study, before we jump into some future looking items, this is one that occurs with a lot of our customer base. So we wanted to kind of put this one out there and say you're not alone. This is one that a lot of our customers can get through very quickly themselves with simple guidance. You can see that it wasn't a large amount of downtime hours saved, as this is a customer that is very familiar with our machinery. They own hundreds of our machines across the world, so they have a very technically sound skill base. But it also helps just to have certain recommendations from time to time, even when troubleshooting these nuisance issues. So in this particular case, a customer actually had a damaged control screen for the machine. So something had bumped into it, broken the corner of the screen, and it was causing issues with the touch of the screen. So this customer, again, being experienced, they went to replace the screen, and as they started to boot up, they started to receive different errors back from the system. So the first error being a communication error and it not allowing the control to boot. This typically causes other problems, which we're going to talk about here in a second, which actually related back to the second one. But when these connect, we actually have to address these items directly on the machine so that the machine knows what to talk to. And if it doesn't see it, the software doesn't match and it won't allow the control to boot. So very quickly, we were able to say, okay, it's missing this certain piece of communication. It's likely going to be something with the settings on the new component you replaced. And once you replace these dials, it will see it again and start working. And lo and behold, that ended up being the issue. Unfortunately, from there, when the control tried to reboot several times, it caused some of the memory to be corrupted in a corrupt state. But usually we can retrieve missing values with a soft start or a cold start on the control. We're actually able to do that remotely as well. So we were able to assist this customer with a remote cold start, something that the customer could do. They have to go get a keyboard, they have to know some simple commands, but it's also something we can do relatively easily in just a couple clicks remotely. We were able to help them cold start. The control booted up successfully. But also, while they were doing this, they took the time to perform a few other maintenance things in the cabinet. During their time in the cabinet, one of the boards for the drives actually had become unseated as they were working around that component. I think something got bumped. It caused a loose connection, and now all of a sudden the machine, the pumps won't start. Now what's wrong? So with that, we were able to actually say it's this drive. We looked in, we can see the communication is missing here. It's this drive. We recommend you reseat that, and luckily that got the machine up and running again. So a few different issues with this particular one, but this is something that we see very common across the customer base. Just general communication errors, things our customers are very good about being able to replace these things with their electricians, but sometimes even the most skilled electricians need help even with simple issues. And when stuff isn't booting up, it's just really good to have that guardian angel there to kind of help back up and back you up and make sure you're getting the right information and not spending countless hours troubleshooting issues that can be solved relatively quickly. So for the last 10 minutes or so here, what we want to do is kind of go through again, some of the things that we're doing with customers today, but also some future looking things that we're headed towards here in 2020 and 2021. So last week we introduced you to the pyramid, the empowered tiers and the applications. We started down here at Advantage and worked our way up and kind of talked about some of the perks and things that we try to help customers with and try to tackle with each different tier. Down here, specifically, what we're talking about is technical support. So in each different tier, technical support is included in some form or capacity. And what we're trying to do is leverage data streams and leverage our connected base to provide additional benefits through our connection. So this is really what we're going to spend the last few minutes to talk about is how do we grow from just being able to be a break fix, call me when my machine's down, to proactively looking at this data and providing recommendations to our customers. On this slide here, this really goes into how we're taking this data. And again, I said on our case study 3 how we're looking at these things and trying to say how can we better service our customers by providing better recommendations, and this kind of highlights that and summarizes it very well. So looking at a select batch of machines, we have a sample here of 350 hours of downtime over a week time span. Through that 350 hours, Milacron is actually able to reach out to these machines and see what is causing our customer base or one particular customer the most amount of downtime for these particular issues. This is how Milacron is taking and choosing what to work on, what to proactively target for our customers and put resources towards, and then what to focus on for the quality teams. So if we're continually seeing issues pop up across the product line, across our products in general, we want to make sure that these are not continuing to happen throughout the years. So we're looking for ways to proactively reach out, but then also build into our technology ways to fix this. And anything is unforeseen, how do we adapt that technology in the future so that we can easily pass updates to these things, so that you're not being continually bugged with either nuisance alarms or alarms that could be alleviated altogether, through simple recommendations. Today, we're doing that through reports and working with some people that we're going to see here in a couple slides. But really, the towards the end of the year and into 2021, we're actually dedicating resources to what we've dubbed our empowered command center. So we've seen the futuristic technology people sitting around these screens and actually analyzing things, waiting for downtimes. Think of like a NASA control center, and we're really going to take that same approach for our customers. So we're very very excited about taking some of this data, some of the other bullet points that I'm not going to go into detail here on, but looking at energy stats for our customers, looking at set point changes and tracking and quality, just based upon the data that we're able to read. And we're very excited to take this data and have people centered around studying it and centered around being a better partner for our customers. So this is something, again, we're trying to be more proactive about, and we are building towards, and what Milacron sees as the vision for 4.0. I also encourage the audience in week 3 and 4, we're going to cover some additional points that really relate back to this. So when we start talking about energy consumption and some of these set point tracking and changes, there's going to be some very, very interesting applications that you'll probably want to learn about if you're interested in those things over the next 2 weeks. And I encourage you to come back and ask questions about those things and really dig into the details with us. One, not only with real world test cases and studies, but then also what we're building towards here in the future. We hope that you can see again through this relational concept of the car that Milacron is all about focusing on how do we build this technology into our machines to help our customers. So I'm going to again refer to a term that I defined last week, which again, AI, I think everybody, I'll briefly say everybody thinks of that as artificial intelligence, but we've kind of coined that term for augmented intelligence, meaning we want to take this data and provide the most amount of information we can to our customer base to make the right decision. We don't want to make the decisions for you. We want to be that partner that helps you make the right decision to keep your machine running effectively, efficiently, and cost effectively for the future. We often get asked, how are you going to do that? How are you doing that today? And behind us, behind this support platform, is just a small group of the people we have supporting that. So what you see here, just encompassed on this slide alone, is 450 years of combined experience of what you're used to talking to on the phone. So these are the same people that are going to be guiding our techs, guiding our technical support, guiding our customers. When you call in and say, I have a problem, well, chances are it's going to be one of these people leading the effort on the back end to make sure that that problem gets alleviated. So we're focusing with great intent on how we take that knowledge and how we use it to eliminate downtimes for our customers. So not only here, but we're focusing on training our technician base, where we have 70 plus trained technicians in the field that dwarf the number of years that even this group has. Taking our Indian and European base engineering staff and support, and bringing them into the fold as well, so that we can support older K-Tech controls, so that we can support Ferromatic machines. I had mentioned the extrusion lines. We are taking all of that information and all of these people, and we're trying to get them with the tools in their hands to provide that better customer experience. So lastly, before we jump into the Q&A, our wrap-up slide here, I just want to draw us back to, every week we're going to try to start and draw back to this relational concept of the car. So today we talked about one individual piece of that. Next week, I encourage you again to join us as we talk about some additional relational concepts, these concepts that can help you understand, if you're thinking about the car aspect, the performance, if you're having continual issues with downtime on a car, categorizing those and really getting tools in place that can help you understand your car on a deeper level, and understand how to take these tools and analyze it and make sure that it's running at its optimum performance and optimum level. So again, thank you for joining us through this, and again, I hope you join us next week for those. And now I'm going to pause and turn it over to Janice to see if there's any additional questions, and jump into the Q&A portion here.
Here's a question, Eddie. What kind of 1 in 5 issues can be resolved remotely for injection molding machines? How functional and efficient is remote access?
Great question. So the four issues I talked about were just some of the many, right? So in a lot of cases, we can help narrow down to particular parts, particular software, other types of issues that might be hard to diagnose and troubleshoot. So we troubleshoot electronic alarms, software alarms, any kind of even processing alarms. We have processing experts that we can connect with the equipment to help diagnose and troubleshoot. So we have a lot of different groups that can touch this and provide support. We even have engineering that can help with updating controls. So we've recently started to experiment with passing complete control updates out into the field, and have successfully done this on many occasions now. So there are a lot of areas we can help as far as types of issues and things that we can diagnose. Like I said, all the way from the virtual issues to the real life mechanical issues. And as far as speed and reliability, we've had great success when it comes to the efficiency of remote access. So if you're running on a 5 megabit connection for your plant, I can say it's probably going to be pretty laggy, and it might take us quite a bit of time to get the same data as somebody that has a 100 meg or 200 meg connection to their plant. But as long as that signal is good, we have very, very good troubleshooting capabilities. And even in those instances where we necessarily can't get the signal through the customer's network, and through our setup that we went through last week on the security section, we do have the ability to add additional devices for cellular types of connectivity that have proven successful as well.
Another question for you. So will an owner of an IMM have actionable insights on his HMI, or get its insight on a registered email or mobile device?
That's another great question. The immediate solutions are going to be provided in the form of an email alert. So being able to go back to a set number of users, and they don't have to be even involved in the system. They don't have to have a user log into the system. But when you put their email in, they will get a proactive reach out that says, here's these things in an email format. Eventually, once we start to put more, once we start getting more things under our belt and we start getting more things into our library, we are evolving this to where it will work with the mobile app. So you'll get push notifications to your mobile app. And then in our next generation control, the next generation control will have the capability to also push this data back down to the users in that format as well. So it's something we are building a lot of features into our future looking technologies to be able to support that.
Thanks, Eddie. Here's another one. Are the most common errors capable of being compiled internally? Will those be shared with manufacturers based on their machine fleet?
Yeah, so if referring back to the slide where we discussed the potential downtime, or that list of downtime codes that we're looking at across the fleet, we are taking that data and we're analyzing it, but then we're also giving it to our customers and saying, here's an overview of your fleet. This is what errors that by occurrence and what errors by time have taken the most away from your machines. This has already provided very helpful in certain situations for our customers where it's okay, yeah, that hour of downtime that I experienced across that one machine, we fixed it relatively quickly. It wasn't that big of an issue. But when we took that same error code and applied it to a 15 machine look at that particular customer, they were very surprised to discover it cost them 40 hours worth of downtime in a 2-week period. They put a lot of effort into making sure that issue was resolved completely. So it's something where the user isn't necessarily pushed into interacting with it themselves. The machines do this for us. So it's very handy to have something automated that says, here's a downtime code, here's what we do to solve that, but then also here's the amount of time that the machine actually sat down. So you're getting all of this automated data that's pushing you in a direction that generally we've had to have people automatically or going themselves, manually entering this data, whereas today the machine can tell us a lot of things on its own.